In this video, we're going to go ahead and take a look at a couple different things that we can now begin to say about the binormal vector, as well as some things that we can do to calculate it more simply. So let's take a look here at the starting definition. First off, we'll notice that something interesting happens here with the three vectors that we discussed so far. We have t, our unit tangent vector, n, the unit normal, and b, the binormal vector. And when we put these together, you might recall something. First off, the tangent vector and the normal vector were always at a right angle to each other. But the binormal vector was also going to exist perpendicular to the two other vectors because it was created as a cross product. But when I put these together, notice that they are kind of almost serving as like an x, y, and z axis. However, they need not actually be running parallel to the actual x, y, and z axis, but they kind of serve a similar function because they're all orthogonal to each other. So oftentimes what we kind of can imagine is that like on a curve that's existing throughout 3 space, at any given point I could sketch out these vectors and kind of create like a new mini coordinate system at this point in time. And so this is what we commonly refer to as a TNB frame, and it's something that's like really, really useful if you're trying to like model things that are moving throughout 3 space and you need to describe like motion relative to those objects. We'll talk more about this in a later section as well, that like these vectors of t and n can actually represent other real world quantities like velocities and accelerations. And so when I start to think about like objects in motion, and I'm thinking about like programming physics in a video game, like understanding kind of like where an object is and motion relative to it kind of in this coordinate axis like way at given points in time can be extremely advantageous. Now, one of the things that we want to talk about here to kind of round this section out is an alternative way to calculating b of t. Remember that we saw that b of t could be found by doing the cross product of t and m. But again, I said at the end of the last video that that was sometimes going to be cumbersome if I was given a problem like here in example 4. Because if I was just told like out of the blue, here is an r of t function, find me the binormal vector, I have to go through the work now to actually find n of t, to find t of t, and then calculate a cross product. And that can be really annoying. But this formula here serves as a possible shortcut if I haven't already done that work. So let's take a look at how this plays out. Really what I have to do here is I would just need to do the cross product of just r prime and r double prime, and then just divide by the norm of that cross product. So let's take a look at how this plays out here in example number 4. Okay, so I'm going to go ahead here and just really quickly note what each of my derivatives is going to look like. So my first derivative here has components negative sine of t, cosine of t, and 1. And my r double prime is going to be negative cosine of t, negative sine of t, and 0. Well, notice that I'm interested in calculating b of pi over 4. So I'm actually going to jump right to evaluating these at pi over 4. Notice that this gets me negative square root of root 2 or negative root 2 over 2, a positive root 2 over 2, and a 1. And in the second derivative, I get something very similar. I get a negative root 2 over 2, but another negative root 2 over 2, and a 0. Okay, so now if I can find the cross product of these vectors, I'll have my numerator for the fraction. And then if I can go ahead and take the norm of that resultant cross product, I will have the denominator and I'll have my b of t established. So I'll state here, we calculate r prime of pi over 4 crossed with r double prime of pi over 4 is equal to. I'm going to go ahead here and set up this cross product. Okay, so I have negative square root of 2 over 2, positive square root of 2 over 2, 1, give myself a little more space here. All right, so if I calculate this out, let's see, what am I going to get here? It looks like I'm going to end up with a positive root 2 over 2 for the first term, or first component, a minus square root of 2 over 2 for the second component, and for my final component here, it looks like I'm going to get a 1/2 plus a 1/2, and that ends up as a 1. You could double check me on that, but I'm pretty sure that that's accurate there. And so if I want to finish this calculation off, I can simply now look at the norm of this resulting vector. Well, the norm is unbelievably easy to calculate here. This is going to be, let's see, the square of root 2 over 2 is going to be a 1/2 plus another 1/2 plus 1. And so I end up here with the square root of 2. And so my b evaluated at pi over 4 is simply going to be my square root of 2 over 2, negative square root of 2 over 2, comma 1, divided by that root 2. This is ultimately just going to leave me with the final vector 1 over 2, negative 1 over 2, and 1 over root 2. And I got it. So this again allows me to kind of skip all the work of calculating the n and the t. Now, I'm going to highlight one final thing before we end this section, and that is that actually in our work here, in all the previous examples, we actually did calculate n of t, and we did calculate t of t. So it is actually completely possible for us to have done this problem, a slightly different way. We could have simply gone back and looked at our previous examples. So I'm going to go here and just quickly note that from example 1 and 2, we had already established that t of pi over 4 was negative 1/2, positive 1/2, 1 over root 2, and that n at pi over 4 was equal to a negative square root of 2 over 2, another negative square root of 2 over 2, and a 0. And so if you wanted to, you could say that instead of using that above formula, imagine this was on a test, right? If part A again was calculate t of t, part B calculate n of t, and then part C comes along and says calculate b of t, well, then doing this formula is actually more work now because I've already done all the work that I need. So here, I could say that we could just calculate my t of pi over 4 crossed with my n of pi over 4. And I'll skip the work here, but I'll leave that for you to go double check on your own. But if we were to do that, I can guarantee you that you're going to end up with the exact same answer that we did up above. All right, so that's where we're going to end this section. You should feel comfortable with some practice at calculating all of these different vectors, kind of understanding what they mean and how they all relate to each other. And of course, if you happen to have any questions, by all means, don't hesitate to ask.